Okay, so for part 2 of exam 2, we're going to basically set up our calculations to find the net flow rates and the root finding to constrain the net flow to internal nodes to 0. And we're going to do this using the suggested flow network and using the initial guesses for Z and K. So the first thing we're going to do is go ahead and set up the array of pipes, the from nodes, the to nodes, the length, and the K. So let's go ahead and set our pipes equal to an array for NP, and that is going to be from 0 to 1 to 2 and then back to 1. Here we have to use brackets, I just remembered that. So we're going to go ahead and replace those parentheses with brackets, or else Collab is not going to be happy. Okay, so we have that. Next, we're going to use, and actually one of these before is actually going to be in parentheses. So next we're going to get the bracket out again and go from 0 to 30, and then back to 1. Then we're going to go from 1 to 2 to 5, back to 1. And then 2 more. We're going to go from 1 to 3 to 0.1 to 6. And finally, we're going to go from 2 to 3 to 0.1 to 6. Close both of those brackets and then close that parentheses. Alright, so we have our pipe set up. Next, we're going to go ahead and set our Z variable. I'm going to set that equal to np.array and go back to our parentheses bracket. We're going to go from 15 to 0 and throw in 2 more zeros. Yeah, 2 more. So let's see, there's a comma. Okay, so we have that. Next, we're going to set our external pipes for the indices. So our external P, set our indices equal to from 0 to 3. That's our interval. And then we're going to go external P. It's going to be equal to our NP dot array from 0 to 0. Okay. Alright, we have those set up. Now we're going to set up the from node. So we're going to call it from node, set that equal to our pipes. We're going to use a colon here to start it and go to 0. Okay. And then we're going to do dot as type, and then our np dot int32. Alright, we're going to go to node next, set that equal to our pipes, do the colon again to 1, is type np32. Okay, now we're going to set our lengths equal to our pipes from bracket colon to 2. And then finally, our K value is going to be equal to our pipes from 0 to 3. So, pipes bracket or not 0 to 3, from the colon to the 3. My bad. Alright. Have that. And we're going to go up and set up the number of pipes. And pipes is going to be equal to our pipes dot shape for 0. And then our pipe roughness, so pipe EB, epsilon over diameter, it's going to be equal to our NP dot full, and then our N underscore pipes to 0.1. Okay. Next, we're going to do. Now we're going to do pipe roughness. That was for pipe diameter. So we're going to do pipe roughness, epsilon over diameter. It's going to be equal to our NP dot full N underscore pipes. That is going to be for 1 times 10 to the negative 3, so 1e negative 3. And then our number of nodes, so n nodes is going to be equal to np dot max. And then pipes, bracket from colon to 0 to 2. Dot as type np dot ing32. Then we're going to go ahead and add 1 to that. Okay, finally, actually, 2 more sections. First, we're going to do the internal indices and then set our flows in net Q and P equal to our functions. So our internal indices is going to be set to list of the set np dot arrange and then our number of nodes dot as type and then our np dot 32. That's going to be subtracted by our set and then external P indices. Next, we're going to go in internal indices. It's going to be set equal to len internal indices. And finally, we're going to set our flows equal to np dot zeros for the number of pipes, and then we're going to set our net Q equal to np dot zeros of the number of nodes, and we're going to set our P equal to np dot zeros of n number of nodes. Alright. That is the code for the first one. Let's go ahead and check that, make sure it's all good. Alright, we have an error. Let's see. Alright, let's go ahead and go back to the top and import a few more things. actually, okay, it looks like I just misspelled pipes as poops, so looks like our end pipes is not defined in line 17. Looks like forgot to capitalize the P for this one. That one's fixed. Next we have the NP zeros is not defined. So I just forgot to put the period there. Some careless errors. Alright. Can now go on to the next line of coding. We're going to set the heads equal to np.zeros for the number of nodes. And then our p is going to be multiplied by the external p indices. We'll put that in brackets. And set it equal to our external p. Alright. Next we're just going to do the set up calculations for the average external head for our internal head guess and then our internal p guess. So for the average, we'll just call it EVG external head. We're going to set that equal to np.mean for external p over row times g. And we're going to add our z, and then in brackets we're going to have external p underscore indices bracket there. And then that's next one is for our internal head guess. We're going to set equal to our np.full and internal indices, and then next line would be the average external head that we just defined. And then finally our internal p underscore guess is going to be set equal to our internal head guess that we just defined. And then we're going to go ahead and subtract our z times our internal indices. And then close that off. And then multiply by rho and g. Okay, so let's go ahead and run that. Everything looks good to go. I'm going to go ahead and stop there for now, and then pick it up in our next video for part 2.